In this session, I'm going to talk about using the different kinds of loops and repeating a set of statements using R, though it is highly not recommended to use these loops and repeats as they slow down the system quite heavily. But sometimes we can't help, we may have to use them, and that is where I want to concentrate on. Now, anything where a particular index I, some specific variable I, it takes on a sequence of values 1, 2, 3, 4, 5. So an index I takes on a sequence of values, and those many times one or more lines of commands are executed. So when I say 1 to 5, step 1, x1, x2, x3, three statements need to be executed. Then 5 times these 3 lines of statements need to be executed. So that is what we are calling as a loop. Now, just like in many other programming languages, even in R also, we have a very simple syntax like this. For I, in 1 to 5, means I will start taking values first 1, then 2, then 3, then 4, then 5. So I will actually go ahead with these kind of values. And what are the commands here? It's only one command, print I squared, right? So if I have to do that, probably let me execute it. For this should be in bracket. Look at the syntax here. I in this entire thing needs to be in brackets. So whatever the values that I is taking, so I is taking 1 to 5. Then if it is one line instruction, just write it next to it. Print I squared. So it is printing 1, 4, 9 because first I will take a value of 1. Then I squared is 1. Then again I will take a value 2, 2 squared. So that's a simple way we are using a for loop to repeat the process. But sometimes I may have to repeat multiple lines, right? For example, I'm taking some value, let's say j is 0. Even I'm taking k is also equal to 0. Now I'm repeating the process. For I in 1 to 5, now I want to repeat a series of steps, not just one line like in the earlier case. Now wherever I want to repeat, I have to use this curly braces. So whatever are the curly brackets, wherever they are beginning and ending, that entire set of statements will be repeated. So I'll put a curly bracket. Now whatever I want to do, right? Probably I'll say, so now I is becoming 1, right? So I'll say j. Now I'll increment j. So I'll say j equal to j plus I, something. And I'll also say k equal to k plus j or k multiplied by j. Anyhow, okay, k plus j multiplied by I, some such kind of calculation I want to do, right? And so like this I want to loop it, and finally I will also say I is, no, I we are not going to look at. So finally I want to print let's say k, right? I want to print k, and this is where I want to end. So all these statements, so what will happen first? Initially I will become 1. When I becomes 1, j is becoming 1, right? J plus I, so j is becoming 1. K is becoming 0 plus 1 multiplied by 1. K is becoming 1. So that is what is typically happening. Then again, when I is becoming 2, the same logic again continues. So let's look at it. So when I is 1, let's see the implementation. When I is 1, j is j plus I. Initially j is 0. So 0 plus 1. So j is becoming 1. K is becoming 0 plus 1 multiplied by 1. K is becoming 1. So print K is printing 1. Now I is becoming 2. So j is becoming, earlier j is 1. 1 plus 2. Now j has become 3. And K already has become 1. 1 plus 3 into 2, 6. 1 plus 6 is 7. So it is getting printed as 7. Now K has become 7. Now the same logic, I became 3. Now J was already 3. So J has become 3 plus 3, 6. Now K has become 7 plus 6 into 3, 18, 25. Now that's how the values are getting printed. So whichever I really want to repeat some number of times, I can use this for loop. Some interesting examples we can take. Let's say I want to create a factorial function. Right? We can talk about creating a function as well as using the loop. Right? We can look at both of them together in this process. Or for a simple thing, I want to create a simple factorial for some numbers using a loop. So it's as good as, so I say factorial 1, right? That is the name of the function I want to create. So I'll say function of x. So I'm creating a new function, factorial. So whatever I execute within this bracket, right? Once I close the bracket, that is where my function is getting closed. So initially I'm assigning a value 1 to one of my variables. So let's say I'm saying one of the variables f is taking a value 1. Then I'm using some if statement. If the value of x is less than 2, just come out of this entire loop. So I'm saying if x is less than 2, return 1. Because we know 1 factorial is also 1, 0 factorial is also 1. So that's where when we are saying if x is less than 2, I'm returning 1. Now for all other I, right, if x is 5 or something, so that is where I'm using the loop. For I in 2 to x, whatever is the x that we are saying. Now this is what I want to loop it. So because I want to loop it, I can directly put one more square curly bracket. What is that I want to do now? I want to multiply my f with I and assign it to f. So I'll say f is becoming f multiplied by I. Because now I is 2 to start with, f is 1. So f I'll make it 1 into 2, which is 2. And for the next step, it becomes 2 into 3, 6. And that's how I want to go ahead with f. Right? Okay. So I am going ahead with f becoming f times I. And finally, I am returning what is called as f. Right? That is what I am finally returning. Whatever the f that is coming out, that is what is my output. F is getting f multiplied by I, That is where the function is getting over, sorry, the loop is getting over. The loop is getting over, so I am closing the loop. Now I have to return. What is that I have to return for the function? What is the output that has to be displayed? F is what has to be displayed. So I will close even the function also here. So this becomes factorial 1. So if I really see fac1 of 6, now it's saying 720, going ahead with your execution itself. Probably we could have, we don't need this much of complication because it's only a one line of code. I really don't need this brackets as well. I could have written f assigned as f multiplied by I here itself, just to simplify it to some extent. So this is how I can plan for a for loop, right? And if I want to apply the same factor for so many numbers, I can use sapply, because for each individual element of the vector sapply will work. So if I am saying, let's say 5 to 15, for all of them apply fac1. So it takes fac1 of 5, fac1 of 6. So I'm getting different kinds of values. So 1.2 times 10 to the power of 2, which is 120, 720, 5040, 40,320, and the list goes on this way. So sapply is even helping me to apply my own function there once I have written this function. So the loop can help me to write some kind of function because it does a repeated calculation for us. Like the for loop, we also have two other loops which will repeat the process. One is called as a while and the other one is a repeat and break. So the same logic, if you see here, I am creating another function for factorial called fact2. Initially I am assigning f is equal to 1. But one additional thing in case of while loop is I am assigning, so it goes like this. It starts from the last, right? The process starts from the last, and as long as the value is greater than 1, it gets multiplied with f, and there is an auto decrement that we are creating for t. And one more thing is, in the for loop, we were simply using f as a return, whereas here we are using the word return f. Once our loop is over, this is what is our loop. This is the while loop. While t greater than 1, you do a multiplication and you do a decrement of t. Both of them you are doing as long as t is greater than 1. And after that, your function, whatever your final value of f is coming out, that is what you are retrieving. So let's look at that. I am creating a function fact2, right? I am factorial 2. I am creating a function of x. Okay, one input going in. So let me look at what is that first, f, which is used for multiplication. I am still setting it 1. But another intermediate variable I am using, which will be initially assigned to the x. Then I am using the while function, saying as long as t is less than 1, you execute this as a loop. What is that I need to do in a loop? First multiply, update your f with the multiplication of t. So make it f multiplied by t. And at the same time, t, after it is multiplied, let it auto decrement. So which means make t minus 1. So it's like this. Initially t will have, let's say I am talking of 6 factorial. Initially t will have a value 6. Now while t is less than 1, obviously its t is less than 1. Now f is becoming f multiplied by t. So 1 multiplied by 6. Now f has become 6. Now t is becoming 5. The same logic, because still t is less than 1. f is becoming f multiplied by t, 6 multiplied by 5. So it is coming out as 6 multiplied by 5 multiplied by 4, so on. So this entire thing is in a loop. My loop is getting over here. Now this is where so this part is over. So now I am returning the f, whatever the final f that gets computed, that is what I have to return. So return is another word, that's a keyword associated with while. So in while we are manually doing an auto decrement, whereas in for it does an auto increment itself. So we really don't need to do any kind of an auto increment or a decrement, whereas here we have to manually do it. And in for it just what has to come out that has to be displayed, whereas here we have to explicitly use a keyword called return, right? So now just to test out fact2 of 6. Oh, somewhere we made a mistake. While t is less than 1, f is becoming f multiplied by t. T is becoming t minus 1. What went wrong? Function x, f is getting 1, t is getting x, y. Oh, t is less than 1. Sorry. Execute it as long as t is greater than 1, right? So this loop has to be executed as long as t is greater than 1. Yeah. So let me make the necessary correction. So I'm saying fact2 is a function. So f is allotted a value 1 and t is allotted a value x, while t is, so in the bracket you are keeping while t is greater than 1. This is where your loop is. So because when I wrote while t is less than 1, obviously it is not less than 1, so it has not even gone into the loop. That's the reason return f, it has given me 1. So if I put while t is greater than 1, I can say f is f multiplied by t. T will be auto decremented and my loop is ending, and then I am returning f, and that's it. This time let me check what is happening. This time we should get it. So when I say fact2 of 6, now it gives me 720. So we have to be just thinking through the whole logic. When should something be executed? And the same thing, we have a third kind of loop which uses repeat and break. Probably this is called as while and return kind of a loop. Whereas this one, I call it repeat and break. Even if you look at it here, the execution is more or less the same. The only thing is we don't start with while here and we don't put the condition. In while we put a condition, whereas in repeat we are directly starting, but internally we are putting the condition. If t is less than 2 or less than or equal to 1, break. Otherwise you carry on. The same thing, f is f multiplied by t, t is t minus 1, all that is the same. So inside the repeat, you will tell when to break it. So fact 3, if I am going with, I am creating one more function. So this is how the function needs to be created. So I am creating a function x, wherein again I am allotting f is 1, I am allotting t is x. This process is the same. Now I'll simply say repeat. So I'll not put any rule here. For while, I have to put the rule here. For repeat, I'm not putting any rule. I'm saying this process has to repeat. But initially I'm putting if if t is less than or equal to 1 or less than 2, break. So this, where should I break? I have to mention it here. And otherwise, I can very well go ahead. F is f multiplied by t, and t is getting auto decrement. Right? All these things are simply fine. And once I am out of the loop, what I have to return is my f. So after that, even my function is getting closed. So from here, I can simply say fact3 of 6. Even this should give me the same 720. So these are the different ways in which I can write my own functions, I can write my own loopings, which can help me to implement my own functions quite comfortably. However, again, as R is a vector language, there is, to a large extent, I can avoid the loops wherever possible. We really don't need to repeat a lot of things because R applies any kind of a calculation to the vector per se. So wherever you can avoid the loops, you can avoid them. Right? In some cases, probably you can use if-else kind of a structure. You can still avoid without going ahead with a loop. And because the loops typically take more time to execute, and that is where you will lose the performance of the system quite drastically. However, in some cases you can't avoid them, so that's the reason we really need to be aware of how do we use the three major kinds of loops. Probably even if one of them is there, it should be sufficient. The for kind of a loop is more easier. For I in something, execute a series of steps. Once you are out of the loop, you just need to mention what needs to be returned if it is a function, right? So for the same logic goes with while and return kind of a function. While is do a particular thing while something is while some logic is executed, and the repeat with a break. All right. So these are the different important loops that you really need to be comfortable with. If you have any further queries regarding these loops, you can get back to me by giving me a call on the number below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.